Okay, let's talk a little bit about transformers. What I'm holding here in my hand is a very common transformer that would come out of an air handler and an AC system. This particular one can be 230 volts or 120 volts on the primary side and 24 volts on the secondary side. So these go out a lot. You're going to replace a lot of these. Sometimes you're going to buy one that's not going to have spades like this. It's going to have wires. That's okay. What you want to match up is the volt amp rating. So we certainly have to have the right voltage input and the right voltage output, but we got to match up the volt amp rating. Most of what we use is a 40 VA. Okay, so if we're going to replace a 40 VA, we can never go smaller. We can go a little bigger as long as our output and our input voltage are the same, but we can't go smaller. So if we wanted to replace a 40 VA with a 50, that'd be okay, as long as the voltages were the same. Now on this board behind me, you can see I've mounted just a few transformers just to show some differences. Look at this guy here, quite a bit bigger than the 40 VA, so this probably is 75. It could still be 115 or 230 on the input and still be 24 on the output, but it's got a bigger VA rating. It's going to do a bigger job. So if we've got electric heat or a commercial unit or something where we require a lot of amperage on our output, on our secondary side, we would need a bigger VA transformer. Most of the time, replace it with what you took out, okay? Now, these various types, some have wires hanging off of them, some don't. Not a big deal, nothing we can't handle. Here we go here, a couple of wires hanging out. If it was spades, I would just simply crimp on them and plug them in. Easy to do. So we've also got some transformers like this one that not only does 230, 115 on the primary, but also does 460. So if I carry this guy in my truck, I can just about replace anything I'm going to run into residentially and maybe light commercial. So I could carry a couple of choices versus multiple choices. If I'm having trouble with one where I'm having a secondary side and it's tripping my breaker or my fuse, I can put this one in here and I won't keep buying transformers because I will just flip the little circuit breaker while I'm diagnosing and trying to figure out what's going on. So on this display, what I have going here is I have my meter connected up here. We'll turn on the light. And what that meter's reading is my secondary voltage on this transformer on the top. This is my secondary voltage. My primary voltage coming in is 110. I've just simply got it plugged into the wall. So I've got 110 volts coming in. My primary coming out is 24. Now we're reading 27 because the thing about transformers you need to know is it's a ratio. There's windings on this side, there's windings on this side. It's a ratio of the amount of windings. If I had an equal number of windings, I would have the same voltage coming out as coming in. If I have 10 times or 20 times difference, then the ratio is going to drop. For example, if I get my 110 volt transformer is giving me 24, then it's about a ratio of 1 to 5. If I hook up to the 230 volt side, it's about a ratio of closer to 10. If I hooked up to the 460 volt side, you can see it's going to be double that. So the display here is to demonstrate two things. Number one, that we're going to watch the voltage drop. 110 is going in, coming out on the secondary. We can see it here, 27 volts. So the transformer did what we asked it to do. Now for demonstration purposes, I hooked it into the secondary of another transformer. So I got the 24 volt feed, in this case the 27, feeding another transformer's normally outlet side, just to prove to you that the transformer doesn't care which way the voltage comes in or out. It's going to ratio it either way, up or down. So now we're going to take that 27.57 and we're going to increase it. We're going to increase it to light this light bulb, and I'm going to show you that it did increase it. When I screw this light bulb in, that light bulb is now lighting because my 24 volts on this transformer fed into the 24 volt side of this transformer, and because we fed it backwards, it raised the voltage to over 110 to light this light bulb. All right, so why did I show that to you? To demonstrate, number one, that the transformer goes up or down, doesn't matter. Number two, and more importantly, is if you ever feed a transformer wrongly, if you run, say, let's just say 110 into the secondary side, and we've got a ratio of 5 times, that means it's going to come out at 500 or 600 volts. Okay, you don't want that. If you feed 230 in to the wrong side, it's going to come out like 10 times more. It could be 1,000 volts coming out. So where does the transformer normally hook up to on the secondary? Thermostats, things that we normally would touch and not pay a lot of attention to. If we feed that transformer wrong, those voltages are going to be very high. So we want to be very careful. So on transformers, the thing is, make sure we get the right size voltamps, make sure we get the right size voltage on the primary, the right size voltage on the secondary, and then we hook those voltages up correctly. I like that one better.